Hi guys, let's take a look at the question where we have a ball X of mass 10 kg that is moving eastwards with a velocity of 2 meters per second. It then collides elastically with another ball Y of mass 2 kg, which was moving with an unknown velocity Y. Immediately after the collision, ball X comes to rest and ball Y moves eastwards with a kinetic energy of 36 joules. And they've kindly drawn a nice diagram to the visual learners. 4.1. Explain the meaning of the term elastic collision. So, a collision is elastic where both the total momentum and total kinetic energy are conserved. Okay, 4.2. Calculate velocity of, or the unknown velocity that they've just told us there. So it's elastically, right? So we are going to use our big formula to calculate it, right? Because it's elastic velocity. So we're going to calculate initial velocity, the sum of the initial velocity, and the sum of the final velocity of x and y. So I'll write down your formula, expand the formula if you want to. Okay, let's give them names. We call that mass x, initial velocity of x squared, plus mass of y, and then initial velocity of y squared. And that is going to be equal to half of mass of x and its final velocity squared, plus half of max y and its final velocity squared. All right, so what has been given? They've been given the masses. They gave us the masses. They gave us the initial velocity of x, which is 2, and they gave us the final velocity of x, which is 0, and they gave us the kinetic energy, the final kinetic energy of ball y. So what can we do? So the mass of ball x is 10. The initial velocity which was given was right there, 2 meters per second, and I'm going to square that. Then my mass of y has been given as 2 kg right there, and the initial velocity of y was not known. Remember, it was moving with an unknown velocity. So that is the one that is unknown. Then, remember, final velocity is when ball x comes to rest. When something comes to rest, that means velocity is 0. So when anything multiplied by 0 will be 0. So this whole little equation there will be 0. Then, this is the kinetic energy calculation, right? And they tell us that the kinetic energy after the collision is 36 joules of ball y. So I can literally just write 36 because that is the formula. Then I can do my multiplication. I can divide this, and I can get my square root to get my initial velocity of y to be 4 meters per second to the west. All right, because remember, it moves with an unknown velocity, and they didn't give us the direction, but it is to the west. If you calculate it, you'll get westerly direction. Okay, because it has to collide, right? So it has to move this way. So it has to be a west. Okay, then the balls were in contact with each other for 0.1 seconds during the collision. 4.3. Calculate the magnitude of the force that ball X exerted on ball Y during the collision. So they want the magnitude of the force. So what can we do? We can use this little simple calculation here to get the magnitude of the force. So 4.3, please jot down the formula. Remember that P is equal to mass times the change in velocity. So they have given us the time. They said they collided for 0.1 seconds. We know that the mass, they want that ball X exerted on Y. So the mass of ball X, remember, is 10. The final velocity of x is 0 and the initial velocity was 2. So then we do our math calculations and we find that F net is going to be 200 newtons. Or you'll get negative, but then you'll have to put it as 200 newtons. And what do they want? They want the magnitude, so you don't even have to write a direction if you don't want to. And that is it, guys. See ya.